brief review of exponent laws. If you're pretty good with these and or have seen them recently, then you can skip this video, but I just wanted to have it out there. And basically, when we look at a to the n, and I'm going to think of n as a whole number, so for example, let's say a to the 5, this is going to be a times a times a times a, n of those. So that's just shorthand. So in other words, a to the 5 would be a times a times a times a times a. And then we have a to the minus n. And so think of a to the minus 5 as our example. That would be 1 over a to the n. So that's just going to be 1 over a times a, n of them all together. And so 1 over a to the 5 would be 1 over a 5 times. Okay. And then we have something about exponents and negative exponents. If we want to multiply a to the n times a to the n, so let's say a to the 3 times a to the 4, well, we'd take n a's and m of them, and we'd multiply them. So the total number of a's is going to be n plus m. So in our example, we'd have a times a times a. That would be a to the 3 times a to the 4, a times a times a times a. That's going to be a to the 3 plus 4, a to the 7. Okay. Now, next thing we want to do is a to the n times m, and that's going to be equal to this. Because really what you're doing is you're taking a to the n times a to the n times a to the n, and there's going to be m of those. And so that's going to be, that's n of them, another n is 2n, all the way up to m of those. So you get a, n to the m. Okay, so let's do an example, a 2 cubed. That's going to be 3 copies of a squared. So there's going to be 6 of those. So that's a to the 6. And if you want to see it worked out, it's a times a times a times a, which is a to the 6. Okay. So we have another one, some special ones, but I want to do this one first. A 1 over n, that's going to be the nth root of a. And then if I have a to the m over n, I think of it as this, a 1 to the m to the mth times. So that's going to be the nth root of a, m of those. So another way to write that would be a to the n times a to the n, sorry, nth root of a, nth root of a, m times, and I can bring all of these inside the radical, so this would be equal to this. So that's a, make that a little bit clearer. So this is what a to the m over n is. The way that I remember this is I look at the bottom one, that's the root. Bottom goes to the root. And then the top one goes inside the radical. Okay. So a couple of special ones. We have a to the minus 1. Well, that's going to be 1 over a to the 1. So if a is equal to 7, then that would be 1 over 7. If a is equal to 2, 2 to the minus 1 would be 1/2. Okay. And if I had 1/2 to the minus 1, that would be 1 over 1/2. And then so you would, you invert and multiply when you're having a fraction over a fraction, so that would be 1 times 2 over 1, which would be 2. But that makes sense. The reciprocal of 2 is 1/2. The reciprocal of 1/2 has to be 2. Okay. And then the last one is a to the 0. And I'm going to give you an example. This is going to be 1, and I want to explain why. First of all, it makes math sense, but let's look at a to the minus 2 times a to the 2. We would take 1 over a times a squared times a squared. That would be a times a over a times a. Everything cancels and we get 1. One last thing, and I should have done this on the last page. Let me do it up here where there's a little bit more room, is that if I have a to the m over a to the n, that's going to be a to the m minus n. So let's look at that. If I have a to the 7 over a to the 5, I have 7 a's up here. I picked a number that was too big. 7. I have 5 down here. And notice cancel, 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 cancel. I've got 2 left. That's a to the squared, which happens to be a to the 7. How many I had on top minus how many I cancel. Okay, so that's a quick review of exponents.